Assalamualaikum and hello. Welcome to our video. Today, we are going to present about application of differentiation for our MAT183 video presentation. Let's get into it.
So, what is differentiation? Differentiation is a method of finding the derivative or rate of change of a function. It is a process to find the instantaneous rate of change in function based on one of its variables. The rate of function is defined as dy dx, fx, and y. Let me introduce to you guys 5 applications of differentiation that we had learned. They are related rates, applied maximum and minimum problems, Ross theorem and mean value theorem, analysis of function 1 that conclude interval and concavity, and analysis of function 2 that conclude relative extrema, derivative test, and graph. As I mentioned at the beginning of the video, related rates will be explained thoroughly. Related rates are rates of change associated with two and more quantities that are changing over time. It involves finding the rate at which one quantity changes with respect to another related quantity that is also changing. In other words, if one rate is known, it can be determined how the other variable is changing. Examples of related rates in real life is watching a bouncy ball being blown up and a plane moving through the sky. Procedure of this application is to find an equation that relates two quantities by using the chain rule or the often used method, which is the implicit differentiation.
As you can see from the slide is the given of the problem statement. If the radius of a sphere is increasing at the rate of 4 cm per second, how fast is the volume changing when the surface area is 16 cm by the power of 2? There is the hints from the question above, where the volume of sphere equals to 4/3 pi r the power of 3, and the surface area of a sphere equals to 4 pi r the power of 2.
Question gives us a sphere with a radius. The volume and the area is given in the question, which is volume equals to 4/3 pi r cubed and the area is 4 pi r square. dr/dt, which is the radius, is 4 cm as -1. We need to solve for dv/dt when the area is 60 cm square. To calculate dv/dt, we need to put dv and dt separately, and we put dr as denominator and numerator, so that dr can be cancelled out. When the volume equals to 4/3 pi r cubed, we need to do differentiate to find dv/dr. 4/3 pi r cubed, and we just take the 3 to the front, and it will be 4/3 multiplied with 3, and the cube will be -1. Then the 3 will be cancelled out, and the answer is 4 pi r square. Then we substitute all the information that we get. dv/dt equals to dv/dr multiplied with dr/dt. Then we substitute dv/dr, which is 4 pi r square, multiplied with 4, which is dr/dt. And the answer will be 60 pi r square. Now we will use the area equation. Given area is 60 cm square, and the equation for the area is 4 pi r square, and it will be 4 pi r square equals to 60 cm square. Now we need to find the r, which is the radius. We will move 4 pi to the right, and we get 60/4 pi. 60 and 4 can be divided and we get 4. R equals to root 4 over pi. Now we need to substitute all the information that we get. So dv over dt equals to 60 pi multiplied with root 4 over pi. The pi then can be cancelled out and we will get 64 cm cubed as minus 1. That's the answer.
Finally, to sum up, we are able to understand related rate, also known as rate of change, problems. This involves geometry formula and function. The procedure is to find an equation that relates the two quantities and then chain rule or implicit method to differentiate both sides with respect to the time.